Hello everyone and welcome back to this video. So today we're gonna take a look at Terraform, Helm and ArgoCD and how these tools can help you to deploy your applications inside of Kubernetes. But without further ado, let's dive in. So our voyage starts at the very beginning inside our application. So we have a simple Java application here that's built with JIP, via Cradle, and we are building this, of course, in our build pipeline. I'm using GitHub Actions here for this. So we will now do this locally. So I will run JIP. That will build a container from my Java application. Takes a couple of seconds, and it will also be pushed to a registry so that now that we can go to the command line and say docker run and call my image here. It will be pulled, it will be started, and we are golden. So we now have our image pushed to the Docker registry. So next up is Helm. So what exactly is Helm? Helm is something that nicely packs up as a package your Kubernetes configuration files. So if you're already familiar with Kubernetes, you know we have a lot of these YAML files here. For example, for the deployment of the application itself, we usually have a service that connects to the deployment so that we can connect to the deployment from the outside. We can have some kind of ingress controller to have it accessed via the browser. And of course, we have some configuration. While we could just apply these with kubectl, it is much more convenient to package these as a package, as a so-called Helm chart. Speaking of charts, we also need this chart YAML here for Helm. So this has a chart version and it has an app version. These are two different versions. So this is the version for the chart itself. So whenever you do a configuration change to the chart, you should update the version. And this is the version of the application itself. So think of our container we built earlier. And then we also have a values file. That's also an important benefit we have Helm here. So we have these variables. Our image name we built earlier is one of these variables. And we can simply pass in these variables. For example, here we have the repository and our image name here to our charts so that we can have some configuration and we can exchange things via a variable. These are the basics of Helm. We then have two options. We can either push our Helm chart to a Helm registry, or we can just install them locally. So to install them locally, we can use this very complex command, which is basically Helm install. We set some variables from the outside. So remember, these variables we have here, we can also override them with the set command. So what I'm doing here is basically that we have to set the host name from the outside. I will not type in this command. So you see this is already conveniently packaged in this shell script here. And then I can go to the command line and I can just say stack up. And this will basically do just the Helm install here. So with the Helm install already running, we see that our application has been installed and that we can simply access our application. So this is our application, very simple. We can do say my name, and it will do say my name, and it's running. I can, of course, also bring down everything, will stack down. This will do Helm uninstall. And then our application should be gone. So that's one application. What if we want to install multiple applications? So for this, I go to my upper folder here, which has a quality service, a person service, also with database. And I have another script, this one, which just basically crawls the directories and repeats the steps. So doing stack up here will now crawl the directories and it will bring up all the applications. Takes a minute, but then it's there. Okay. And of course, I can also bring everything down again. Okay, so while this is working, the question is here, is it convenient to have a bunch of bash scripts that also have to check the outcome? So if there is an error or something went wrong and react to this. So in former times, we are using tools like Ansible, but now we have some better options here. So with Terraform, we can reach the next level. Terraform is basically also a CLI we can just download from their website and we can call it. For Terraform, we need this so-called TF configuration files, and you see IntelliJ has a very nice integration for that. The simple example is that we can have, of course, hello world. So this will basically just output a hello world to the command line. So what we can do here now is we say Terraform apply. It will ask me to enter yes. If I really want to do it, I say yes, and it tells me hello world, and there we are. What you might recognize in the background, it will create this so-called state files. And that's a very important thing. Terraform saves the state of the deployment in the state files so that you can later take a look what is already deployed and what's not, and to create a diff from that. So while a hello world is nothing too exciting, let's take a look on how to create some Docker containers. So now the first change that we see, we have a so-called provider now in here, which is called Kreuzberger Docker, which can simply help us to create a Docker container. So we need some kind of configuration here, and we also need to apply the name of the Docker container here. Again, we have my quali service here. And then if we do Terraform apply, we will get an error because it tells us, okay, there is nothing I can do with it. You need to first initialize because we have this provider here. So this time, for one time, we have to say Terraform init. It will now initialize everything. We get some additional directories here. And now we can say Terraform apply. Again, we have to say yes. It will create the service. Takes a moment. And now the service is up and running. What we can also do is Terraform destroy. Again, it asks me, should I really do that? I say yes, and it will destroy everything. And that's one of the key benefits we have with Terraform compared to things like Ansible. This is a so-called declarative approach. So instead of saying Docker pull, Docker run, I just say, I want to have this Docker image installed, and it knows how to install, how to destroy, and also how to update that. So of course, that's Docker. Nothing too exciting here. Let's take a look back to our Helm charts we had previously. So for our Helm charts, we are now in this folder here. You see we have this wrong folder, sorry. We are here. We have this folder here, which is called Callie Service. Let me close my other screens here. And Callie Service is now also a description on how we can install things via Helm. So we see we have this Helm release resource here, which has the name, which has a repository, which has the version here, and then we can also inject some variables from the outside. If you remember, this is what we basically did with our set commands from the bash script. Hosts we also can set the replica count and the architecture. This is repeated again for the person service, so that we have this nice description here, how to install our Helm charts. What we also have now is a so-called main TF. That's the best practice. So things that are common for both of these Terraform files go here. So we say we need a provider, which is Kubernetes, and we need to connect this via this configuration file. And we also have some variables that we can pass in. So our host name here, which is resolved here, that's from these variables. These variables, we can have them in this configuration file, but we can also pass them in from the environment of our application. But that's already too much waffling. So let's again take a look. If we say Terraform apply, if it will install our Helm charts. Takes a moment. Creation. Now we should see that our Helm charts are created. And the nice thing is the services are accessible right now. So the Terraform waits until everything is provisioned correctly, and only then it tells that the creation is completed. We can, of course, also say Terraform destroy. Yes. And it should remove everything. Okay. The question is, how about updating of the stuff? For this, we will again Terraform apply. And now we will change something. So we take a look. We will roll out our application in version 3.1.1. And now we want to upgrade this to a latest version. For this, I need to change my chart locally because currently Terraform is resolving my charts locally. It could also resolve these from a artifact from a registry. So I increase the version here to 1.1.2 and the app version to 3.1.3. And now I will again do Terraform apply. And it should now tell me that there is a change. It will detect the change, it will modify. And we now see here that we have version 3.1.3 installed. Very convenient. Let's roll that back and I will show you another command. If we don't want to do Terraform apply directly, we can say Terraform plan. And this will tell us the changes. So this time it will tell us, okay, our version will go back to the Helm chart version 1.1.1. And if I'm fine with the changes, I can say again, Terraform apply. Yes. And we see it will modify. It will bring down the old application in the 3.1.3 and it will reinstall again 3.1.1. And we are golden here. So let's destroy everything and then let's go to our final part. So last but not least, we have ArgoCD. With ArgoCD, it's a little bit of a different story. So with Terraform, we basically resolve our Helm charts and push them to Kubernetes. While with ArgoCD, that is something that is installed as a daemon inside Kubernetes, and it will pull the Helm charts from a Git repository. The fun part is, however, that we can install ArgoCD and the definition files we need for applications again with Terraform. So this is some kind of nice building block where one builds upon the other. So this is our definition here. ArgoCD itself is a Helm chart that is can be installed. I have a controller folder here. I will again say Terraform apply, but it is already applied. So it will just check and say, oh, it's already there. So we already have it running. And we see here, we have this namespace, which is called ArgoCD, which totally installs everything that is ArgoCD. What we also need are definition files again. So don't be confused. These definition files look similar to the ones we had with Terraform itself, but these are ArgoCD definition files that are just deployed via Terraform. So it's a little bit of a different story, but in the end, it's the same kind of information. The main difference, however, is that our repository is always on GitHub. So every change we want to do needs to be pushed to our GitHub repository. So let's go to our example here. And we say, again, Terraform apply to roll out our resources. So this should give us this. And if I go to Argo UI, I see that my applications are happily deployed. So of course, I can also do something like destroy here, but we are not going to do this now. So if we want to do a change, we can again go to our original chart. We can do the change we did previously. So we increase the app version, but this time it's important that we push everything to GitHub. Push. It's pushed. And now usually GitHub ArgoCD will look every 300 seconds for a change, but we can fasten things up a little bit. So I push this button, this sync button, and it already says me, okay, there is something that needs to be synced. And we now should see here the change. So our version 3.11 is now upgraded to 3.13. There we are. And of course, we can roll back everything. Commit again. Refresh again. And then we should see that everything is rolled back to the old version. Of course, you see for a brief moment of time, both versions are installed. That's just the way how it works in Kubernetes, but now we are back to the old version. So that's fine. And of course, we can now bring everything down. So I go here to my Terraform files. I say destroy. Yes. And then in my Argo UI, I should see that everything gets destroyed. The things are going away. And my namespace should be clean again. Okay. So to sum things up, I have a little diagram here. So what have we already learned? We need to push our container to a Docker registry. From this Docker registry, our Helm charts can resolve our containers here. And then we have two options. We either use Terraform to push the things to the Kubernetes server, or we use ArgoCD to pull them from a Git repository. These are two options, and these have all different drawbacks and benefits, of course. What also needs to be notified is that Terraform, of course, can do much, much more than only installing Helm charts. It has a lot of providers that you can also use to create machines on AWS and Azure, and a lot of other providers. But that's it for today. Thank you so much for joining me, and I hope to see you in the next video. Bye.